This is like video number 8-ish. I don't know. Okay? Yes?
Yeah.
And we can have a commercial. Okay? We can call it, the rug store. You can buy time on YouTube, and you could advertise your rug store. We have 2 students that like to sell me rugs, and they may open up a rug store. Okay? It's a great store. Okay? Am I going to get a phone call about this? We don't know who it is, though. We don't know who it is. Okay? Did I say any names?
No.
Excellent. Okay, fine. Now, so what are we doing? I have no idea. Okay, so we're going to talk about what I said about precision is a function of the number of decimal places. Okay, now we're going to kind of make that a little bit better. For instance, let's take two values. Okay, is this still working? I heard a beep. It's on?
Yeah.
Oh, that was her? Stop beeping, please. Put it on mute. Felicity's beeping. Okay. Oh, said a name. Oh, she's an adult. She's okay. Okay, so 0.0010 and 0.01. What? Okay. Which one is going to have more decimal places? Yeah. Now, I didn't say that they had to have significant figures in them, but let's kind of rephrase what we said. In other words, this has 2 decimal places, or 4 decimal places, and this has 2. But there's significant figures in only 2 of them. So is that a little confusing? Okay, let's look at this one. Let's say 500 with a bar over it, and 500. Which has more decimal places? We'll say this is A, we'll say this is B, we'll say this is A, B, and C. Can you see green? Is green okay? I had some reports that green was not good. Does that come off on the video? You've seen videos. Is green okay? Not the best? Okay? All right. Are we all right? Okay, so this one is, which one's more precise? A or B? Are you done? That was really quick. That was like 7 minutes. Textbook, you saw it right here first. It's on record. 8 minutes to do a whole class. Unless you want to be on. Go this way. Unless you want to be on. Yeah, she doesn't want to be on.
No, thank you.
No, thank you, she says. She's so pleasant even when she says, no, thank you. Okay. So, this one is going to be more precise, right? Yes? Than this one. So it'll be this one. Okay. Which one's going to be more precise, A, B, or C there? Yes? A, B, or C. That's how we're identifying them.
A.
A is going to be more precise. That's correct. 3, 2, 1. You see that?
Yeah.
Okay? Easy?
Yes.
Yeah.
Easy. Now, where are you going to use this? And I just want to give you a little taste of where we're going. Is that okay?
Yeah.
Okay. When you add 2 numbers, your answer, write this down. Write this down. Write this down. When you add or subtract 2 numbers, 2 measurements, let's be specific. When you add or subtract 2 measurements, Professor, are you getting this? Okay. He's playing Sudoku on his computer. Mrs. Minor, I want you to know that. Okay. Brian, he's playing Sudoku on his computer. No, I'm kidding. Okay, so when you are adding or subtracting measurements, okay? When you're adding or subtracting measurements, your answer, this is really cool, your answer must have the same precision as the least precise measurement. When adding or subtracting measurements. It's right out of the book. When you're adding or subtracting measurements, your answer must have the same precision as the least precise measurement. Do you get that? Okay. So what you do is this. This is what I do. It keeps me honest. You ready? Yes? Okay. To the left of each measurement, I put the precision. That's the first thing I do. So what's the precision here in this particular value? No. Plus or minus 10, right? Because that doesn't have a function, does it? Doesn't have a bar over it, doesn't have a point there. So the precision here is going to be tens place, correct? Isn't that right? Okay. Then I circle it. Okay. Yes, with another colored pencil. What's the precision here for this measurement? What is it?
Plus or minus 1.
Plus or minus 1. Okay. Then I circle it. Yes? Okay. Then I circle it. Okay. And then I determine which one is less precise. Is it going to be the upper one or the lower one?
The lower one.
The lower one, what did I say?
More precise.
Did I say the more precise?
Yeah.
Okay. All right, there's the lower one. Therefore, which one is the least precise? The upper one, correct? Yes? Now, what is the precision of the upper one? Plus or minus 10. So it's that, right? So what you have to do is you have to round the answer to that precision. So what's the answer? We know mathematically that's going to be 40, right? Isn't that easy? Yeah, so I do it mathematically, and then over here I say 40, okay? Then I write in the correct precision. It has to be what? Plus or minus 10. Does that number have a precision of tens place? As it's written.
Yeah.
Then that's the answer. Correct? You see that?
That's the answer.
That's the answer. If you put this, it would be wrong. No credit. 0. Because that's plus or minus 1. Is that what you said?
Yeah.
Excellent. If I said that it was like this, what would the answer be? It would be that.
Yeah. Plus or minus 1.
It would be plus or minus 1. Right? And you'd have to put that decimal point in. If that decimal point wasn't written in other words, 40 does not equal 40 point. This is science class. We're working with accuracy and precision. Why do you have to correctly represent the precision? Yes, anybody? If someone is trying to verify your results, we call that replication. It's part of the experimental process. Somebody in Astana, what's Astana the capital of? Anybody? Estonia, that's Tallinn. It's Kazakhstan. You guys are international students. You should have some familiarity with some capitals. I'm not impressed. I want you to know that, okay? Estonia? That was a guess. Okay, so it's important because if someone's going to reproduce your results, they want to know what kind of precision you had. Yes? If you represent the precision as something which is 100 millionths place, that's really a very precise value. And for precision, you used a shoe for length. Now, you could have used billion-dollar equipment to measure volume and density, all that stuff. But you had a couple of length measurements, and this is what you used. You used the shoe, this is size 46. You divided it up into 46 equal places, and you said, well, that measurement is, okay, 1 2/46. Well, what's that mean in decimal? What's 2 divided by 46? 2 divided by 46 is 23. We've got a lot of work to do. 46 divided by 2 is 23. What is 2 divided by 46?
0.0.
She's actually trying to estimate it. I love this. Go ahead, give me your best shot. I love this.
0.043.
0.043. Somebody take out a calculator, their phone, something. What do you got?
0.043.
Oh, wait a second. Wait a second. What's the actual answer? Wait, I got to write this down. What is it? My new student here, let's write this down. Go ahead.
0.043. 0.043.
0.043, and you said 0.043. All right? What's the conclusion? She used my Birkenstocks on her experiment. That's what she did. I know you. You used my shoe to do an experiment. I'm kidding. That's really unbelievable that she got that, isn't it? I'm impressed. I'm impressed. I am impressed. Excellent. I still think you stole my Birkenstocks to do an experiment, but I'll forgive you. Okay, now. So what is your experiment, the precision of your experiment based upon? The shoe. The least accurate value. That's the weak link. You've heard the expression, the weak link, isn't it? Wasn't there a show, The Weak Link? Yeah? Yeah. Did I say that right? The weak link. Doesn't sound right. Weak, W-E-A-K, link. Oh, the weakest link. Okay. I stand corrected, I guess. But the idea is that, you used all this billion-dollar equipment, but your precision is only as good as the worst piece of equipment, and you're using a shoe. Right? I know. It probably never happens. But do you get the point? Yes or no? So when you're talking about precision, the most precise value, you really have to look at, all of the place values that are written in, even the place value holders. I didn't say with a significant figure in it. Clear? I didn't say it has anything to do with significant figures, did I? Did I? Accuracy is a function of significant figures. Let's say I have a reading on one instrument and it's 44. Okay? I take that same amount of material and I put it in another instrument and it's 44.01. Which one is going to be closer to the actual value? 44.01. So I have 2 significant figures there, 4 significant figures there. Well, guess what? What is going to be more accurate? The one with the greater the number of significant figures, correct? You get it? So does the decimal place thing make a little bit more sense?
Yeah.
When you're talking about precision, it's decimal places, correct? Where these are all decimal places. Yes? Okay. Talk like this, sounds better. Okay, when I talk like this, I get, All right, you get it? You understand? Yes or no? Yes? Okay. Okay? A little confusing, and we'll make a little bit more sense out of it. There's another thing that we can say relative to precision to come up with a more operative definition. Okay? Clear? Yes or no? Okay, now, there are videos, the old ones, where you put, gentlemen, thank you for paying attention. There are videos, if you go all the way down to the end, right, of the videos, the oldest video is on scales and significant figures. If you go up from there and look at them, right there, then this one's on atomic theory, that's chapter 4. But this one is the last one I put in for chapter 3. So you look at all these videos. Clear? I want you to look at them all. Every one. I'm putting 2 up this weekend, 2 big ones, 3 big ones. The first one is reading scales practice. Good? The second one is a lecture on the entire chapter where I literally read the chapter and talk about the chapter, with my own narration as well as reading the chapter. Yes? The third one is I list every question and then every answer comes sliding in. Read the question, read the answer, read the question, here's the answer, question, answer. Clear? And that's another movie. So every question in the book, every answer in the book is on the video. Clear? Is there any reason for you not to get 100? wax on,
Wax off.
wax off. So it's always wax on. There's no reason. Right? Yes? How many people have no idea what I'm doing? What movie was that from? Karate Kid. Wax on, right?
Not the new one.
Not the new one?
Second one.
Yeah, I do that a lot. Okay, understood? We're off.